Today we're talking about how AI actually thinks and why you should care. You type a question, and it answers like a person who has read the entire internet. But here's the unsettling part. It is not thinking like you at all. It may not be thinking in any way you'd recognize. So what is actually happening in those few seconds between your question and its answer? By the end of this, you'll understand what's really going on inside the machine, and you'll never be fooled by it in quite the same way again. This matters because hundreds of millions of us now ask AI for medical advice, legal help, money tips, code, and homework. If you don't know how it works, you can't know when to trust it and when it is confidently, fluently, completely wrong. Understanding the machine turns you from someone it can fool into someone who can actually use it well. No math degree required, just one big idea and a handful of surprises. Let's open the box. Here is the single most important idea, and everything else builds on it. At its core, an AI like ChatGPT is a prediction machine. It does one thing, guess the next chunk of text. That's it. Everything else, the essays, the code, the advice, is a side effect of that one trick. Think of the autocomplete on your phone. You type, "I'm running late, I'll be there in," and it suggests 5 minutes. A large language model is that exact same idea, scaled up almost unimaginably. It is autocomplete that swallowed a library. Your question becomes the start of a sentence the AI is trying to finish. It predicts the most likely next chunk, adds it on, then predicts the next and the next, building its whole answer one little piece at a time, left to right, like dominoes falling. It is, quite literally, an autocomplete so powerful it can finish your sentence with a working computer program, a poem, or a step-by-step explanation. Same trick as your phone, just a far, far bigger machine behind it. Quick example. Give it, "The cat sat on the cat," and it predicts Matt, because across nearly everything it ever read, that's how that sentence ends. Now hand it a physics question, and it is doing the exact same thing, just over a vastly larger, stranger space of possible next words. But it isn't predicting whole words exactly. It works in tokens, chunks of text. A token might be a full word, part of a word, or just a few letters. The word thinking might be split into think and ing. It's reading and writing in puzzle pieces. This is why AI sometimes miscounts the letters in a word, or fumbles simple spelling and rhyming. It never really sees the individual letters the way you do. It sees tokens, and at every single step it is juggling tens of thousands of possible next ones. And here's a common mix-up. This is not a search engine. By default, it is not looking anything up, not fetching a web page, not opening a file. It generates each answer straight from the patterns baked into its dials, which is why it can write something brand new and why it can invent a source that never existed. So how did it learn which token comes next? Here's the surprise. Nobody programmed it with grammar rules or a list of facts. Instead, it was trained, shown an enormous slice of the internet, books, and code, and made to play one simple game over and over. The game: take a real sentence, hide the next word, make the model guess it, then reveal the real answer. Do that billions upon billions of times across trillions of words, nudging the machine a tiny bit toward the right answer every single time it's wrong. To get good at that game, the model is forced to soak up patterns, grammar, facts, tone, cause and effect, even the shape of a joke. Predicting the next word well, at that scale, secretly requires learning how the world tends to be described. And the scale is hard to picture. These models train on more text than any human could read in 1,000 lifetimes, and the training itself can take months, on warehouses full of specialized chips burning enough electricity to power a town. One big consequence of all that training, the model is frozen at the moment training ended. It has a knowledge cutoff. Straight out of the box, it doesn't know what happened yesterday or last year. Anything after that date simply isn't in the dials, unless the app lets it go search the web to catch up. So where does all that learning actually get stored? Not in a database of facts you could open and read. It's stored as numbers, billions of them, called weights, sitting inside a giant connected web we call a neural network. Picture an unthinkably large board of dials, billions of them, all wired together. Training is just the slow process of turning each dial a hair at a time until the whole machine gets good at predicting text. The knowledge is the final setting of all those dials, nothing more. When you send a prompt, your words become numbers, flow through this web of billions of dials, and come out the other side as a prediction for the next token. It feels like magic. Underneath, it is multiplication and addition, done at a staggering scale. It also doesn't treat your words equally. As it reads your prompt, it decides which earlier words matter most for the next guess, linking the word it back to the right noun, or a question back to its subject. That trick, called attention, is a big reason modern AI suddenly got so good. Now the mind-bending part. How does pure next word prediction produce something that can explain physics or debug your code? Because language is not just words. Language is compressed human thought. Our reasoning is baked right into the sentences we write. To predict the next word in a math proof, you have to capture something about math. To finish a legal argument, you have to capture something about law. By learning to mimic our writing, the model absorbed a blurry, secondhand copy of the thinking inside it. So when it feels like the AI is reasoning, it is replaying the statistical shadow of millions of humans who reasoned on the page before it. It's standing on a mountain of our writing and echoing it back to you, remixed and recombined into something new. Here's a useful way to picture it. The model is like a blurry, compressed photo of everything it read. Ask about something the internet covered a million times and the picture is crisp. Ask about something rare or obscure, and it goes fuzzy, and that fuzz is exactly where it starts filling in the blanks by guessing. Which leads straight to its most dangerous habit. Because the model predicts what is plausible, not what is true, it will sometimes invent things, a fake court case, a study that doesn't exist, a made-up quote, and deliver it with total, smiling confidence. Before we go deeper, here's something you can do about that false confidence right now. Down in the description, I've dropped a prompt that hands the AI a confidence scale. It makes the model rate how sure it is on every answer and flag the parts it's shaky on. It won't kill hallucinations, but it drags that confidence out into the open where you can catch it. We call this hallucination, and it is not a rare glitch it occasionally suffers. It is the flip side of how it works. The very same machinery that writes a beautiful true sentence will, just as smoothly, write a beautiful false one. It cannot tell the difference. The model has no built-in sense of fact versus fiction, and, this is the key, no sense of what it does not know. It cannot feel uncertain. It just predicts the next confident-sounding token, whether the answer is rock solid or pure fantasy. So here is the rule to tattoo on your brain. Fluent does not mean correct. The smoother, calmer, and more confident an AI sounds, the easier it is to forget that it might be completely making the whole thing up. This is why AI can feel brilliant and weirdly dumb in the very same breath, nailing a hard exam question, then insisting 2 plus 2 is 5, or that a simple word has the wrong number of letters. Its skill is jagged, because it mirrors the patchy patterns in its training, not a tidy understanding of the world. Here's another surprise. By default, the AI does not actually remember you. Each new conversation starts as a blank slate. It only knows what is inside the current chat, a limited space called the context window. Think of it as the machine's short-term memory. Everything you've said in this chat gets quietly fed back in with every new message, which is how it seems to follow the thread. But close the conversation, and unless the app deliberately saves notes about you, that version of it forgets you ever existed. And it has no goals, no feelings, no inner life ticking away between your messages. It is not sitting there pondering. It does nothing at all until you hit enter. Then it predicts, then it stops. Between prompts, there is simply no one home. Now, the honest caveat. Whether any of this counts as real thinking is a genuine debate among serious scientists, partly because we still can't fully explain our own minds. But on the evidence we have, there's no sign of an inner experience in there. It is astonishing behavior with, as far as we can tell, nobody behind the eyes. Now, you may have heard about newer reasoning models that seem to think harder. Here's their trick. They're trained to write out their thinking step by step before answering, to scribble on a mental scratch pad and talk themselves through the problem first. It turns out that predicting one careful step at a time, out loud, leads to much better final answers than blurting one out. But notice what's really happening, it is still prediction. We just gave the autocomplete room to show its work, like a student told to. That's a genuine improvement, not a different kind of mind. More steps, more computing, better patterns, better results. But underneath the longer, smarter-looking answers, the engine is the exact same prediction machine we've been describing this whole time. One more quirk that trips people up. Ask the same question twice and you often get two different answers. That's because the model doesn't always pick the single most likely next token, it rolls a weighted dice among the top choices, which is what makes it feel creative instead of robotic. And because it learned from us, it inherited us, including our blind spots and biases. It is a mirror of the text it was trained on. When that text leans a certain way, so does the machine, quietly, unless it's carefully corrected. So what do you do with all this? 3 habits. First, give it context. Since it only sees what's in front of it, the more relevant detail you pack into your prompt, the sharper its prediction. Vague in, vague out. Second, verify anything that matters. Treat its facts, numbers, quotes, and links as confident first drafts, not as truth. For anything with real stakes, health, money, legal, safety, check it against a real trusted source before you act. Third, use it for what prediction is genuinely great at: drafting, summarizing, brainstorming, translating, explaining, and unsticking you when you're stuck. Then stay skeptical the moment you need guaranteed accuracy. It's a brilliant, tireless intern. It is not an oracle. One bonus trick that falls right out of all this: tell it to think step by step or give it a role. Act as a skeptical editor. Because it's predicting from patterns, steering those patterns with clear, specific instructions genuinely changes the quality of what comes back out. Where is all this going? The models are getting bigger, the context window's longer, and they're learning to reach for tools, searching the web, running code, checking their own work to patch over their weak spots. But the core trick at the center isn't changing. So here's the one thing to remember from all of this. AI doesn't know things, it predicts them. It is a staggeringly powerful pattern machine, echoing humanity's own writing back at you, fluently, confidently, usefully, and every so often, completely wrongly. Understand that, and you'll already get more out of these tools than 90% of the people using them. If you want to go deeper on exactly when and why these models lie, and how to catch it, that is our very next episode. Subscribe so you don't miss it. See you there.